Hi everyone, today we are going to talk about the second lab, which is dealing with the alternator, open circuit, short circuit, and load test. So we will talk first about open circuit test. So we will use the synchronous generator. We will leave these terminals opened. What we are going to do, we are going to use the DC motor as a prime mover for our synchronous generator. And we will connect the DC motor to lead this guy. And then we will try to leave this guy open. And then we will try to measure the terminal voltage. And we will try to measure the field current as well and find the relation between the terminal voltage and the field current. So let us make that connection. What I would like to do here, I would like to connect my DC motor. So I will connect these two. This is the shunt field, and I'm using this guy as a field rheostat to be able to change the field to adjust the speed of the synchronous motor, the synchronous generator. And I will connect my device in shunt. This guy is the armature. So by changing the value of the field rheostat, I'm going to change the speed of the DC motor. And by the way, I'm going to change the speed of the DC generator till I reach to 1,800 revolutions per minute. Then I would like to feed this guy by a DC voltage. So I will connect the DC voltage here. This is my power supply, and it is connected to those 2 points, or those 2 points because they are connected in parallel. Right now, my DC motor will start working. So if I turn this guy on, I can start adjusting the speed. By the way, I'm using this guy, which is the tachometer, for measuring the speed of the DC motor or the speed of the synchronous generator. And by adjusting the location of this guy, I can change my speed. So let me turn this on. Now I adjusted my speed to 1,800. So by using this guy and by changing the field rheostat, I adjusted the speed of this guy to 1,800. So the next step is to connect my synchronous generator. And I'm going to leave those opened. And by the way, I would like to measure the armature current for the DC motor. So what I need here, I will use this guy as a meter to measure the DC current to the armature for the DC motor. Then I will connect these 3 guys as Y connection. This is phase A, phase B, phase C. I connected them to be a star connection. This guy is open circuit. And I will connect the DC field. This guy is the exciter. And I'm exciting the synchronous generator by DC field. So I will connect this guy to DC field. And I will change this to be longer. I will connect as well a meter to measure the armature current, the field current for the exciter for the synchronous generator. So I need to connect here this guy. Let me put this down. So I1 is measuring, this is my ammeter. So right now, this guy is measuring the armature, the field current for the synchronous generator, and this guy is measuring the field current for the DC motor. Now what I would like to find the relation between the field current and the terminal voltage for open circuit test. So I need to connect this guy to measure the line-to-line voltage. So this guy is connected in parallel. I will change this. So E1 is measuring the terminal voltage, and I1 is measuring the field current for the synchronous generator, and I2 is measuring the field current for the DC motor. And that's it. This is what I need. What is the next step? I'm going to change for the field current by using this variac. And by changing the field current, IF for the synchronous generator will be changed. And as a result, V terminal will be changed. And I will monitor that by using the data acquisition system like what you are seeing here. This guy is adjusted to measure E1 AC. And I don't have E2. I have I1, which is DC, and I have I2, which is I2 is DC, and I1 is DC as well. Then I will turn my machine on. Then I will start changing, like what you are seeing here, V1. And this guy is measuring I1 and I2. I will try to change the field current. This guy is representing the field current, and I will try to measure the corresponding V terminal, change the field current and measure the corresponding V terminal, and so on. I'm doing that in steps till I reach this guy to be 0.8, I will stop. So I will measure this guy and this guy, change again, measure this guy, change again, measure this guy, and so on. This is what is needed for that lab. I would like to find the relation between the terminal voltage and the field current for the synchronous generator. I'll see you for the next lab for short circuit test. Bye for now.